So I would say that's why we blew $2 billion recently in VC money and going public as SPAC and all that, is because the hardware guy was getting so much money, but they were actually not doing something mind-blowing.
Welcome to the Additive Advantage Podcast, where we cut through the hype to talk about what it really takes to turn additive manufacturing into real business results. Each episode, we sit down with industry leaders, engineers, and innovators to explore how organizations are moving beyond prototypes and pilot projects and building scalable, production-ready capabilities. Whether you're evaluating additive for the first time or working to expand its impact inside your organization, this podcast is designed to give you practical insights, real-world perspectives, and a clearer path forward. Let's get started.
Today's episode will be a masterclass in perspective. We're joined by Tuan TranPham, someone who spent over 2 decades in nearly every corner of the additive industry, from metals to polymers, and now fiber additive manufacturing. He's been with some of the OG companies like Objet. He's also, his current company FiberSeek is on the cutting edge of what's happening with the Asian influence on our industry. In this conversation, we're going to go beyond the hype and dig into what's actually holding additive back from scaling, and more importantly, what needs to change for it to deliver real business impact. I'm counting on Tuan to bring perspective from all of these different roles that he has held in the different companies he's been with. If you care about where the industry is going and what it will take for us to get there, this is one you're not going to want to miss. I'm excited to come to you today with Tuan TranPham. Welcome to the podcast, Tuan.
Thank you, Sean. I'm very happy to be here. Thanks for having me.
You bet. I think we would probably not do this episode justice if we didn't start with a little bit of background. We could probably do an entire episode just on, we could do a biography of your adventures in additive, but tell us a little, give us a high level overview of kind of the various parts of the industry you've been in and the things that you've seen over your time in additive.
Sure. So here's the short version. Well, it starts with 3D printing is my accidental passion. I grew up in Copenhagen, Denmark. I studied business engineering. I didn't know about 3D printing. I moved to the US because of a girl who's not my wife. Ended up in Boston, which turns out to be the world capital of 3D printing, given MIT and Harvard. So I've been very fortunate to spend 23 years in 3D printing, spent the first 10 in plastics, and then very quickly saw the potential of metals. I've been spending quite a long time in metals as well, with Desktop Metal and Archem and others, but only to realize that the most neglected material is composite between plastic and metal. And so I joined Avivo, and now I'm with an isoprint, which is now rebranded towards the prosumer market as FiberSeek. So it's always been curiosity that has been driving me in my journey in 3D printing. I've only worked for manufacturer. I like to make my dent in the world by impacting and influence products that the market will consume. So that's the short version.
Thank you for that. Given all that, I want to start with, if you've consumed a little bit of the content we generate on this podcast, we spend a lot of time on what it takes to help additive succeed at scale and how to avoid the pitfalls that undermine so many projects. So I want to start, based on all that background, with a little bit of an industry overview. Tuan, I'm curious, based on everything you've seen, what do you see as customer needs that exist today that as an industry we're not yet doing a good job of meeting?
Well, I haven't seen it yet in the industry, so I'm working on this. This is what I'm calling customers' bill of rights. Have any manufacturer really asked the customer what they want? Okay, so let's say 3D printing is 40 years old. We still have 10 years before we supposedly to be peaking. But what do they really want? In the past, they would just try and consume and learn what additive can offer to them. But what do they really need? And the short version is, I think what they really want is they have a need for making a product, and they have done that traditionally for decades. In many ways, 3D printing is like CNC 40 years ago, and oh boy, has CNC matured since then, and now is even on the desktop. But I think the customer want a part. They have done it traditionally, but if they want to reduce costs or increase the performance, they want to try out additive. And the truth is, as long as the material property, the quality of the part, the performance of the part, the material spec is met, so quality is non-negotiable. But that's what is the first criteria. Once you meet that, they really don't care that much about what material. Ideally, they want to use the same material that they use traditionally. But if the material property is good enough and exceeds that spec or meet that spec, the next question is really about cost per part. They really don't care whether it's a carbon machine, a HP machine, or what brand. They don't care about the brand. They don't care about the technology, the print engine. They want the cost per part. If you don't make the financial sense, they will never actually take it to make it commercially from their product offering. So I think what they want in addition is because of potential future pandemic and geopolitical conflict, they might want it locally just in time, avoid tariffs, supply chain proximity. But really, they want a solution. They want high quality, non-negotiable, and they want it at a price that is at least 10%, if not more, advantage and enticing for them to even making the switch to additive. Did I kind of answer your question?
I think you did. And I'm curious because everything you mentioned there, you talk about quality, material selection, et cetera. These are all things that you would think as an industry we would be doing. And I'm saying we, all of us, we'd be doing a better job of. Why do you think the industry is still missing the mark in so many cases?
It's kind of like a chicken and egg because let's say, in my opinion, materials is so 3D printing is hardware, software, materials, and the process styling it in to have repeatability and consistency and quality, blah, blah, blah. But I think materials is what I realized after a decade is the most critical component of the three. Hardware is actually the easiest. And that's why the manufacturer did the easy part, just doing the hardware. And then, dear customer, you figure out what you want to do with it. I don't care. I'm just making the machine and I'll keep it running, but I don't know what you're going to make and I don't care. That has to change. So I think what happens now is really the customer want a solution. They have tried a lot of different technology, different things the last 10, 20 years. They burned their fingers. They have now expensive piece of furniture, and now they want a solution. And they're only talking to people, manufacturer who actually offering a solution and who wants to listen to them. And kind of like what Benign Creation is doing and Carbon is doing and others, they're focusing on a solution. They don't go to making a generalist machine, but really specialize for certain vertical and really understand that vertical, that lingo. If you pick a few the good manufacturers pick a few vertical and go deep, not being superficial anymore.
That makes a ton of sense. I'm curious, when we think about the materials piece, let's start there because you and I see this the same way. The hardware, to a large degree, is the easy part. But when we think about materials, where do you see that innovation coming from? Where is the next big wave of, the new materials, whether it be composites, metals, polymers that are going to a 3D printed material that most closely mimics the performance of a traditional material? What do you see on the horizon and where do you think that's coming from?
I like your focus on that question. I think going back to what I was trying to say is the chicken and egg, right? So additive has so we saw like 5 years ago, we saw Henkel, we saw a lot of materials company getting exciting and coming in. But what they were really curious about is selling their leftover. They're already making a ton of money and have been for decades on traditional manufacturing. And they were kind of like lending, hey, can you use some of this leftover or the same for additives? So all these hardware manufacturers is like, okay, they're trying different materials, but it's not exactly designing for additive or the spec, the wavelength, the temperature, 2 epoxy, 1 epoxy. So that was the limited supply chain. Or they can do it themselves, but they don't have the money or capacity and resources and facility to hire another 1,000 scientists, PhD chemists to do the formulation and try. They can't be BSF. And so what they really want for additive to grow a material for additive, they have to do it themselves unless you incentivize those traditional supply chain primes. And that is to get the investment from them. And they're sitting on the board, so they have a long-term gain. Otherwise, if you don't get those ingredients that you need, additive would not fly. Because if additive can print and reliable, but if the material quality cannot meet like UV resistance nearby the window or outdoors, a bike handle or bike is saddle, if it cannot sustain sunlight and UV light, it won't be a product because you're going to have massive recall. So it's a chicken and egg, and we're still having this issue. Very few companies have secured the ingredients and the material that actually can produce high quality. Remember, to go back to the customer bill of rights. Quality is non-negotiable. If you don't have that, you have nothing. So I think what we need is, one, we need to have manufacturers stepping up and do some material, pick one, and at the same time try to incentivize the traditional material supplier to get a piece of the cake long term, get them on the board, get the investment, because it's going to take a while. They have not been patient. If anything, we see BSF and others are pulling out, which is not good for the industry. They were
Right.
dating with us, but now they just broke up with us. And we either need new material suppliers and chemists and scientists and all that. Otherwise, we'll be on our own.
Agreed. It concerns me when you see the big players stepping back, because I think it's unlikely. Obviously, there's a lot of innovation happening in academia and among some of the smaller players in the space. But to your point, to influence supply chain of some of the ingredients to the point that you can get the things you need to manufacture these things at scale under some type of, so many customers that we deal with, when you talk about quality being non-negotiable, they forget the material piece. And they're like, hey, we heard there's this new innovative material. Can you guys take a look and see if we can run this on your platform? And of course, we've got various VAT technologies and all this. We can make just about anything run. But I said, have you looked into the quality of them as a supplier? Is it two guys with a giant veterinary glove stirring ingredients in a 55-gallon drum in a garage? I don't think there's as much of that as there used to be, but there is definitely, especially when you think about anything that's coming out as new, right, from a new company. And I think, again, when you have a large company that says, ooh, we might be able to utilize that material, but can they meet supplier qualifications to even be incorporated into, to your point, if you're going to build it into a product, if you're just going to use it in R&D and prototyping, not a big deal, right? You mess around with a little bit, all of a sudden you can't get it anymore, no problem. If you're going to build it into a product, there's a whole set of supplier qualifications that company needs to be able to meet, and that's a challenge in many cases. Building on that conversation a little bit, what's your opinion of the, I guess I'm going to call it hardware innovation in general today? Do you see anything out there that you think is significantly going to impact additive's ability to perform at scale? Or are we just kind of playing around the edges and fine tuning?
I think from a hardware perspective, remember, the industry has been around for 40 years, depending on who you're asking, when do you count? But the last 40 years, we've done a lot already, big innovation. And what I've seen the last 5 years has been more incremental, doing with the twist, doing non-planar, doing other gantry. But what a lot of sexy new stuff, but not necessarily translating to a product market fit. So I would say that's why we blew $2 billion recently in VC money and going public SPAC and all that, is because the hardware guy was getting so much money, but they were actually not doing something mind-blowing. The only thing that was mind-blowing was metal binding jetting, leveraging on the supply chain of mint powder that already exists. So you don't have a supply issue of materials, but the hardware was also easy to make. But the process, dialing it all in, and I guess ahead of time, they were missing the software piece, the AI and the shrinkage and so that. But in general, to answer your question, I think hardware, most of the exhibition and trade show you see now, they're almost the same. All the parts is incremental, a little bit of twist. I can do a little bit high temperature than you. I can do a little bit bigger than you, but it's not mind-blowing. And the only thing mind-blowing I can see is a volumetric, where you have a resin and it rotates, but it's still teeny tiny. It's still very early days to speed up. The biggest issue, if we can do everything else, the hardware, software, material, but the process, 3D printing is still way too slow. And because we are slow, the speed, the productivity, the cost per part is still very high. So unless we get super fast, hyper additive manufacturing, then we will not be able to really push down cost per part. Remember, that was the second piece, right? You get the material, quality, ingredients, but if you can't get cost per part down, one easier way is to speed up the process. But science is science. Sometimes you can't go faster. You're getting a speeding ticket.
I like your use of that phrase in that context. What we've seen so often, you talk about hardware, software, materials, and then the process around it, speeding up the printing process. I mean, we're known for pretty fast part production, but it's how, are you doing 100% inspection on the parts? What are all the, post-processing, setup. Oftentimes those processes take as much or more time as the actual printing. And we see, I think it's getting better, but we see people still pretty naive. And I want to go back to a point that you made about in the context of this process that has to go around the hardware, software, materials, kind of back to how do we do this better as an industry? Most players in the industry are heavily channel driven. When we think about the expertise that's required to optimize that process, again, not just the printing, not just the material parameters, but to get the part that the customer ultimately wants. How do you do that well through a channel-driven model?
The channel quality varies a lot, and there are very few good ones. And the best one are true automation system integrators like Oyster in Germany. And if you don't have the automation, the engineering, the motivation, and the money to do that, when you say channel traditional reseller, they're just opportunistic reseller. They are not scientific. They just buy and resell. And so that means either it's the OEM's responsibility or hopefully you get a few system integrator because the reseller will not be the one that I will bet on. During my time at Azul 3D in the resin space, I learned it was kind of freaking scary. Imagine you had 100 machine made not by humans. They are made by humans, but let's okay, they are like Harley Davidson, they're human made. But let's say they were identical. The hardware, the process, all identical. Every screw is the same. But the printing is the myth is the printing is hard. No, it's not. Actually, printing is the easiest part. But the post-processing, remember 5 years ago, we barely had enough supply chain ecosystem of the post-processing. So whether your resin is a one epoxy or dual mixing epoxy, the ratio between the two, the time, the temperature, the mixing, the 100 machine doing exactly the same part, exactly the same time coming out, if they are treated in a convection oven differently, the walking distance, the humidity, the lighting, the UV light, day, morning, evening, all that will give 100 different parts. That's scary.
It is. And that you just said it out loud. It's one of the secrets that, I think a lot of people don't realize because they're only focused on their slice, the hardware piece, the materials piece. They're not out there where the rubber meets the road trying to help the customer get consistent parts. That's where we live. And it's really what spawned this whole podcast is the disconnect in my mind between, oh, hey, here's a cool new piece of hardware and it's 10% faster and it's got 28 lasers instead of 22 lasers. And then dealing with an actual customer trying to get parts at scale. Like this isn't even in the industry. A ton of marketing dollars get spent on this and it'll have a big booth at a trade show, but it isn't helping this problem at all. And that expertise, where we felt like we've been pulled into this systems integrator model because it's the only way to ensure the customer gets the results they need. And, we just proposed on a project literally this week where they run a whole bunch of our tech, but they've got applications that, they're not suited to B9 tech, and they see us as their trusted solution provider. And they said, hey, we need to buy more than one of these other machines. Can you develop a process to essentially performance validate these machines at B9? Because we don't even want them in our building unless you can tell us they're all going to perform a certain way, document that process for us, figure out how do we get those consistent parts every time, and then basically ship it to us once you've developed that overall process and you can tell us how to do this successfully. I think we're going to see more and more and more of that. And I've kind of warned the guys in the factory, like we need to clear out some space here because I have a hunch we're going to be doing a lot of process development around third-party tech in the months and years ahead. When you think about that channel model and obviously doing everything direct, there are trade-offs, right? It's slower, it's heavily people dependent, except I think sometimes the illusion is, oh, well, we'll get out of that individual hiring people dependency by using a channel model. Well, all you did was now you're dependent on their individual hiring and people processes. So where do you put the expertise? Because you've got this, the OEMs, ideally, they would bring some chunk of it. The problem is if they're not the ones that have the intimate relationship with the customer, you've got this disconnect. Is it a matter of the channel partners really need to raise their game? And if they want If they want to be serious, they've got to invest in the expertise. I see you shaking your head a little bit. What's the path forward here? How do we fix this as an industry?
Well, for additive, is a known fact that the best sales and marketing channel distribution for 3D printing last 30 years has been the best in class, the strategist channel. And they're the best in class because they were SolidWorks reseller. They had the content. Without content, you won't be needing printing. But they are good at one thing, that is sales and marketing. That's what you're paying for. That's what they're good at. That's what they've done. They're not going to become super intellectual system integrator and starting to hire a PhD and scientists. They should. They're not. So to your point, I think B9 is on the right track. I think it is the responsibility of the manufacturer, not just in the historical to do case study of to making the part, really making a product and really understand the process. I think what you're doing is the right thing. I think manufacturers should own that problem. So you have, as a manufacturer, have two choices, right? If you are focusing on one or two verticals that is big enough to justify the investment like you do, awesome. If not, then I do like what Brigid is doing at Matilda, trying to bring the ecosystem coming together and collaborate. We have not historically been good at collaborating amongst the manufacturer, but there's still disconnect and handshake between those, putting together a process solutions. I predict for us to go in mass production for 3D printing to be a $100 billion company. We're barely growing $1 billion a year. Instead of doing part marketing benchmarking, we should do process validation documentation, because that's what the customer really want, to get the reassurance and confidence. And then they just want to write a check. They want to get the product delivered, but they want you to prove that the process is repeatable at a quality level, reliable, not the reseller. And they won't do it. They burn so much money and time. They're not going to do that again. What has happened is different. And this explains why, while SLA and SLS has been around the longest, it is actually Scott Crump with the FDM, FFF, the simplest process that has now been able to dominate the industry from an extrusion point of view. And now with Bamboo Labs selling it below 2,000, enable everybody to buy that technology, that product to make something. And so that is a low risk of doing so, but most cool additive hardware is very expensive, and the justification is just not there. They're not going to do the process validation themselves. They need you to prove to them, and then they can start with that template and modify to their need. They're not going to do the work.
Agreed. And I think we have to come up with a way to help the customer understand what level of hardware is enough, right? Not everything takes, not everything takes a B9 level precision, accuracy. There's tons of parts that don't require that. But does that mean you can buy a, $750, or buy 50 $750 machines? Am I going to give up all the gains I made on the CapEx side in scrap rate, inspection costs, because you build so much labor in on the back end, and helping customers? And I don't have any issue. I love that there's a $750 option, but somehow, the customer has to be able to cut through the marketing hype and figure out what can this machine, or what could 10 of these machines actually do in terms of performance window, and what would I expect in terms of part production. Those are areas that, when we think QA/QC tool set, a lot of times people assume we're applying that, and we do apply it to, high-end stuff like 3D printed tooling for ceramic cores for turbine blades, but you can apply that same QA/QC tool set on the other end of the spectrum to figure out what's possible, statistically, using a metrology-based process from lower cost hardware as well. And again, if you can save on the CapEx and not throw it all away on labor on the back end, it can be a great approach.
To your point about the 750, whether it's plastic, composite, or metals, if you look at the context market research report, they are in the worst decline the last 5 years. People are not spending. They're not willing to spend. Remember, going back to, if the quality is good enough, it's just cost per part. And a key factor that you can manipulate is the speed. So like a B9, when it's so compact and affordable, and it's not 750, but let's say it's 7,500, or 30,000, is doable, low risk, low approval threshold. You can have a dozen of these that counter the slow speed to get good quality. And especially if we can get it down below 10,000, and this is why the rights of the Asian dragons are coming because they are below 5,000. So there's literally no risk. You just buy a dozen. If it doesn't work, you throw them out. They're so cheap, but that will counter the speed. That's why you see the rise of print farm, where you now see Instagram Reels, TikTok Reels with print farm of hundreds of a machine. That has never been seen before. So that countered the speed dilemma issue.
Agreed. I think to me, the watch out is how much of a labor problem are you creating on the back end in terms of inspection, scrap rate, et cetera. But if depending on the specific application, you and I've had this conversation before, right? It depends so much on what you're trying to produce. Sometimes that can be a great solution. Well, interesting. And I hope this is not now purely a go-to-market podcast, but I felt like if we didn't leverage some of your background and expertise to explore the ups and downs or pros and cons of the traditional go-to-market model in additive, I felt like we'd be missing an opportunity there. I'd like to shift gears a little bit and have you tell me about, in all of your experience, what is the most successful project you've been a part of in terms of leveraging additive at scale? Let's start there, and then we'll peel that apart a little bit.
That's a difficult question because that is the same as asking me, Tuan, what have you seen over the last 23 years? Can you name a dozen parts that is in mass production, high quality that the consumer can buy? I can't even name you a dozen. Maybe the Adidas midsole, the Fit6 saddle, very few is in successful. But that is because I was in so early, so that historically manufacturers just got excited about inventing the next bling bling and new technology, and they push the channel to sell the product out, and then let's go find a product market fit. So that's why the industry was just doing prototyping and tooling. So to answer your question, the industry is still struggling to go beyond tooling. They're doing very limited high value production run. And when we say high value or expensive, if we talk about aerospace and medical, and now we talk about defense, we have not seen that for what I mentioned to you in the past about. I'm very excited about the consumer space because to answer your question, the application, the part that I've been involved with, they were not necessarily in the consumer space. I tried to do that with Azul for helmets, bicycle helmets, but the material probably was not just there, or actually the booming sport, the pickleball paddle. We were so close to do additive, the pickleball paddle. We worked with the Wilton Sporting Goods, but remember, the threshold for material quality is non-negotiable. And if we don't meet that, it's not going to fly. I would say I've not yet hit that jackpot yet. I've seen companies like Carbon have done that with the Vidal helmet. A simple go-to-market strategy like replacing foam with mesh structures, simple additive, no other way. I think it's smart, it's simple, it's scalable, and it can spread out to a lot. But no, I've not been fortunate. My direction is going in a different way. Is to make an impact on the industry and the world. I looked at history, and I call them the $3,000, the 3K disruptors. What do I mean by the 3K disruptors? Like, remember over a decade ago what Formlabs did with the Kickstarter and SLA machine? Instead of a Viber from 3D System at 180,000, now you can get a Form 1 Formlabs at 3,000. You saw that with even Micronics doing that with SLS, which is why Formlabs had to buy them because it was competing with Fuse One. So Micronics did that on Kickstarter to disrupt the SLS space. Somebody should do that for laser powder bed fusion, but with laser galvo, that's going to be challenging. So that's what I'm doing here with FiberSeek. Is commercial. I think composite is the most neglected material, and I think it has a huge potential. Can you get down below 3,000? That's what we have done. We raised 4.7 million at the recent Kickstarter. So I'm democratizing, enabling the world to make stronger part using FFF or FDM on your desktop. Simple, easy, and consumable is easy, but that hopefully will trigger more potential end-use part. To speculate what that could be, Sean, is it could be drones. Drones
Certainly
need
that's a hot topic these days.
That is, well, why do you need strong power? Why do you need composite? Why do you need continuous? It has to be strong and light. Why does it need to be strong and light? It has to be airborne. If it's not airborne, it doesn't need to be strong and light. Like trains and cars, they don't need to be strong and light. They might be strong, but light is not so much. Maybe EVs and eVTOLs, but anything that flies, definitely, I think we're in the right spot. And that's why I joined the company on the composite space.
Well, one of the areas I think we see a little differently, the mechanical engineer in me, I get excited about 3D printed tooling enabling mass production because of that materials gap we talked about earlier, right? I see additively produced tooling that can utilize a traditional material as the bridge from where we are today as an industry to where we want to be, where we have photopolymers and other things that truly can match the material properties of what a customer is used to using. Obviously, a ton of excitement around drones. I'm no expert in the continuous fiber additive space, but maybe at Rapid TCT, you can educate me a bit. So based on what you just shared in terms of the kind of biggest opportunities, and, we can't point to a consumer product yet that has just been produced at enormous scale. When you think about, I'll go back to your role that you have now at FiberSeek. What do you see as the gaps between where FiberSeek is today and mass production of drones? What are the bridges that have to get crossed to enable that to happen at scale in a distributed fashion?
And so before I answer that question, I want to build on what you said just before is the holy grail is for 3D printing to be in mass production or in production. But where it is today, where we have been seeing success is actually not making the end product, but keeping the factory running. Meaning we do jigs and fixtures and tunes to keep it running. But to your point, we're already seeing for drones already today the demand in defense for drones. But what drones need is strong and light, and they actually want bigger, and they want to be strong because of stronger and bigger payload. So what we launched initially, 10 years experience at an isoprint, doing a compact prosumer desktop metal machine, continuous carbon fiber for 3000. But that's a Fiber Seeker 3. There could be a number 5 that is bigger. There could be Fiber Seeker 7, high temperature. Imagine to do a drone with high temperature with reinforcement carbon fiber that nobody else in the world can do. High temperature ultim with continuous carbon fiber inside because we have a co-extrusion. So I'm very excited of the future, even just drone. But when you say drone, you can also talk about RV cars and other consumer product. And so the two verticals that excites me the most for the future of 3D printing is consumer goods. It has to be for the 8 billion people on the planet today. And if things goes well with the progress, so, tying that to going back, if you read the books about most big disruptors, it takes 50 years to mature. If 3D printing is 40 years old, the industry should peak at 2036 in 10 years with AI, automation, 8 billion humanoids very affordably in 10 years could happen that will solve the labor problem. That means the labor will be 9 billion people on the planet. That's how you get to mass production and part. But when it's consumer product, it has to be high quality. That's where I think is the excitement for the future is defense or consumer goods.
Interesting that those feel like opposite ends of the spectrum. Interesting that that's where you see the two biggest opportunities. I want to go back to the expertise piece of this. We talked about the expertise in terms of the production and distribution, right? Channel, OEMs, et cetera. I want to talk about expertise from the customer side. We have done a number of projects where, the customer has brought technology in. They've had started out maybe with some R&D engineers, moved into some production engineers, and then they want to go prime time with it. But the processes and the technology don't succeed when you get it out of the hands of the engineers onto the factory floor being used by production technicians, basically. How do you view what a customer should do to enable success? Or, where should that expertise sit and where should the production actually happen?
It goes to the question where I think the future of 3D printing will be, and it will be like Amazon, AWS, 3D printing in the cloud. You don't really care about where it is made, but you do want it just in time and locally to avoid tariff. But ideally, customer want the part at the high quality, ideally locally across the street, not necessarily by them, but by a third party like Amazon of 3D printing, who has a supply chain, do it overnight, having a factory of the future with all the possible technology and subtractive and additive and advanced. Or it will be a system integrator who will do it across the street. I don't see a future where the customer will take on that investment and hiring and site facility and prepping and permit to do it all by themselves. I just don't think they just want to write a check. They don't want to do it all in-house. So like if Amazon has a fleet of 1,000 B9s, or you have collaboration with a lot of system integrated in the different region, that is unique. That's why we had a 3D Ginkgos. Well, we had a 2D Ginkgo for 2D printing before everybody had a 2D printing at home. We can learn a lot by looking at the traditional 2D printing. And eventually you do need 3D Ginkgos, but unlike the 2D Ginkgos, these are vertical specific, solution-based, vertical 3D Ginkgos. They do dental very well. They do hearing aid very well. They talk the lingo. They know medical implant. They are the go-to people. I don't see the customer doing it, taking it up on themselves. I think those days are over.
So you think the dental lab model almost, but for other applications?
Give me an example, like
I'm saying
a
whereas
helmet.
no, like a dental lab today, if a dentist wants a set of dentures or a crown or whatever the case is, where that 3D printing Kinko's is kind of like a dental lab, except they would exist not just for dental applications, but others. Is that how you see that
Well,
playing out?
actually, you got me there. Maybe given the size of teeth and dental, maybe it's so small and compact that when B9 they have a total solution that fits on a 6-foot table and total solution, that might be the exception. But I was thinking more like bigger parts, bigger than your head.
Yeah.
That is quite a lot of post-processing. In the dental space, it's probably the biggest and most mature consumer product or vertical in industry. And that's why everybody's going after it. You can have on a typical table, you can have a full ecosystem, full process. So I think that's why they're probably one of the most mature verticals, much closer to the level of a hearing aids as well.
So I'm going to ask you one more workforce question. If you were Tuan 10 years ago, for the kids today who maybe grew up with a 3D printer, this would be the first generation where they didn't have to go to a university or, the first 3D printer I ever saw was during an internship that I had in college. How would you pursue a career in additive? When we think about the expertise gap that exists, there should be a lot of opportunity there. But if I was a 15-year-old today, how would I go plug into that opportunity?
I have a mixed thought on that because 3D printing is more mature, right? 40 years old. Many companies have experience. There are more articles about it. Most universities have it. So it's here and ready. But this generation of kids, what excites them these days? I'm not so sure manufacturing excites them. So that's a little bit worrisome. The market has never been as informed and educated. The information and knowledge is available if they want to consume it. So if I'm 15 and I want to learn this, it's there. You can even go on LinkedIn and subscribe to some groups and learn and listen to podcasts like these and learn really fast and be just like what people say now, learn AI to get a boost in your career while learn 3D printing. Additive manufacturing is part of the fourth industrial revolution. To answer your question in a weird way is, I would say, like Wayne Gretzky, you don't skate to where the puck is, where it's going to be. So where it's going to be, if you look at the World Economic Forum, you look at the components of the fourth industrial revolution that is coming, that is already here, but it's going to mature. If you look at those 12 components, additive 3D printing is one of them, but humanoids, big data, blockchain, anything else, sensors, everything is coming together. The trick is to understand what could come and learn those different facets of AI and 3D printing and put them together into solutions for vertical. That will be where I would go. But also, it's a little bit scary. If you look at the population, we're 8 billion now. In 10 years, we might only add 1 billion. We're actually in decline in terms of birth rate. And with the rise of humanoids, they're getting cheaper and cheaper. Now it's less than 10K, eventually be 1K. I wouldn't be surprised that if this generation of kids don't get smarter faster and learn how to integrate things and position themselves. In 10 years, I would not be surprised there will be 9 billion humanoids as well, both here and on Mars and on the moon. And they would do basic stuff that a blue collar worker can do as well. So that is also a competition to this generation. So while the information for additive is here for this generation, they are going into a world that we did not go through, and it will be challenging, and they need to differentiate, and they need to double down on something. And I would say I would double down on understanding what could come, the components of the fourth industrial revolution, and place your bets on learning integration of multiple of those components. I started this podcast by saying 3D printing was my accidental passion because I didn't know about it. I started 5 years business engineering in Copenhagen. I didn't know 3D printing. Printer, I studied in Manchester. I learned the internet emails back in '96 for the first time in my life. Only when I moved because of a girl to Boston did I stomp on a Z-Corp machine in 2002, fell in love with it. I felt like I was Indiana Jones, excavating glue and powder from start and have a ball bearing and putting super glue on it and have something physical. The future is exciting and scary. Not only AI, robotics, and humanoid, but what if robots can make robots? A 3D printer is a robot. What if a robot can make their own robot, make their own 3D printer to reproduce themselves? It is an exciting and scary world, but we need to control that. That was a long answer.
That's all right. We just need to figure out where Sarah Connor is so that we can protect her and save the future. I'm curious, and actually that your answer to that question leads into what's probably my last question. What do you think, stop short of 10 years to 9 billion humanoid robots? Let's think 5 years. What is the potential of the additive industry as it exists today? What difference can we make in the next 5 years based on where we're starting from today?
One thing that is very clear, actually, a lot of people don't know this, but prior to 3D printing, I was 4 years with Intel. I was in semiconductor. And in semiconductor, what I learned for a fragmented industry that is growing, for it to grow even faster, the rocket booster that you need, it and it is happening, but it's too slow, is standards and interfaces. If you don't have standard interfaces, meaning collaboration, then this industry won't grow. And so it's great we have co-AM collaboration between the three. But if we don't have a standard interface, a multi-source agreement that let's level the playing field, everybody compete, but we're friendly. Let's do what's best for the industry, best for the customer. So they have versatility. They can choose multiple vendors. We cannot even agree on the interface between the different steps. And I think it's very clear to me that that is the biggest hurdle right now. We got 3D printing industry, like we're not even close to take out taxing on the tarmac. And I said that, I don't know, 15 years ago, and we're still doing that because we're not playing. Everybody's selfish. Everybody have their own P&L. They're not collaborating. They kind of say they want, but they're not really agreeing on multi-source agreement and interfaces. So you can connect any printer to any material to any post-processing. It is still very fragmented. It takes a monster to put it all together. Maybe Jeff Bezos, now that they have a few billion aside, maybe he should, besides AI, take AI, integrate 3D printing, and buy a lot of 3D printing company, put it together, and stop the fragmentation and really focusing on a process with standards and take it to and be the Amazon of 3D printing, which HP should have done.
It's interesting. The topic of standards and process comes up a lot on this podcast because, again, we're talking about how do we use things at scale. I will tell you, I have lived that experience in a previous career. I was in the energy and clean tech space with a company called Schneider Electric. And frankly, I started out with a small company called CSI, Control Systems International, that got acquired by a medium-sized company, TAC, that got acquired by Schneider Electric. And my whole career in that space, which was about 18 years, we kept hearing about, you had Siemens, Johnson Controls, Honeywell, Schneider Electric. They all make building automation systems, which are really just control systems. The holy grail was, well, if we had one standard so that if a customer had, if a university campus, let's say they have 30 buildings today and they're going to build a new building. Well, if you have Johnson Controls building automation in 30 buildings, it doesn't make much sense to put Siemens or Schneider Electric in the one new building and then it doesn't talk to the others. So the customer feels trapped. I'm stuck with Johnson Controls. And again, I'm not picking on Johnson Controls. This could have been any of them. And so there were all these dreams and what really became, in my opinion, more hallucinations of, can we come up with an industry standard like BACnet? And there were multiple versions of this that rolled along over the course of my time in that industry. And no one ring to rule them all really ever emerged. Because at the end of the day, if you're, again, and I'm not picking on any one company, but if you're one of those companies and you've got a multi-billion-dollar business around building automation systems, are you going to give away the ability to, you're going to reduce the barriers to switching? And it has, there's some integration at some level, right? But it's not really what a customer would like. I think that's where understanding how to do win-win business and figuring out, you can't expect companies to develop the tech, educate the workforce, put the channel together, develop the processes and all of that, and then just give it away, right? This is probably going to be a little bit controversial, but I actually think, one of the biggest flaws in additive manufacturing has been this desire for, well, everything needs to be open source. Well, show me another industry when we say we need consolidation and we need a few bigger players. How does open source help that?
Hmm.
So I think it would be great if standards like that emerged based on my, previous career. I'm skeptical. My prediction is we'll get some minimal integrations and communication. I think we'll struggle to get that at a high level. And I don't say that because, I don't think it would be good. I just think it's very, very difficult to achieve, especially when the market is fragmented among smaller players. Well, Tuan, this has been a lot of fun. I wish you the very best. Please figure out how you're going to educate me on fiber 3D printing. That's an area I need to learn more about. And
Sure.
to all of our listeners out there, if you're not sure who this guy is, you're living under a rock with no internet access, go check him out online, and look forward to seeing you in another episode soon.
Thanks for having me.
What a fun conversation. You don't always get to speak to someone with such depth and breadth of experience. So there were a lot of things coming out of that I'm not sure would have surfaced with any other podcast guest.
I'm not sure how he has so many fewer gray hairs than I do, based on career path and in the additive industry. But there's a lot to unpack. One
of the things that he said I thought was interesting was this idea of a customer bill of rights. What parts of that do you think the industry needs to improve upon?
Well, you may have to keep an eye on time because this is a topic that I'm pretty passionate about. I love that we're hearing that from someone who's been in every corner of the industry. I think coming as an industry, we are certainly known a lot more for hype than we are for results. When Tuan's talking about customer bill of rights, quality has to be non-negotiable, material properties need to get better. Honestly, I think if companies just actually measured customer experience and customer satisfaction, and we've said this a few times, but our industry is still digging itself out of the hole of companies being designed to satisfy the needs of investors rather than customers. We've got to get the rest of the way over the hump. And I love that he's calling that out as someone who really, when you listen to his passion, it's all about the technology and the products. So to hear him say how important he knows delivering for the customer is, to me, tells me we're kind of at the tipping point. And we're turning a corner as an industry.
Absolutely. And kind of speaking, I'll call it marketing hype. He had an interesting take on hardware innovation too, where he is seeing this more as having plateaued and being incremental gains versus some bleeding edge quantum leap in technology. Do you see that as true? Do you see areas where we are still having these kind of quantum leaps? What's your take on what he shared?
I'm going to come at it from a lean manufacturing point of view. So, in a manufacturing context, if you streamline a part of your manufacturing process, but it wasn't the bottleneck, you didn't make the manufacturing process any faster. And today, not that there aren't improvements that we can gain on the hardware front, but when you look at additive in a production context, the quality of the part or the speed with which the part is produced, I don't see very many applications where that's the bottleneck, right? Not that you can't get maybe some incremental gain there. And I hope that people don't misinterpret this as poo-pooing innovation in hardware. That's not at all my point. My point is simply that until we move the bottleneck, which is really eliminating 100% inspection of parts, having some type of QA QC system in place on the front end, being able to have certificates of conformance, and to be able to build a QMS approach around the additive production piece. Until we have those things, printing the part faster is of minimal additional value, in my opinion. Again, interesting that a guy who admits his passion is the tech and the products would come forward with that realization. And say that publicly. I thought that was a sign of the transparency of the conversation we had.
Yeah, I think I want to double click on that because you spent a lot of time talking about the role of post-processing and process in terms of projects that succeed versus projects that fail. And for someone, to your point, who's admittedly into the tech side, that's a big focus on implementation and manufacturing. Do you see that as true in either some of the other guests or customers that we've worked with? And how should people be thinking about that portion as the incremental gain they should focus on?
Well, I think you're really getting at the heart of why we have this podcast, and really the biggest hurdle our industry has yet to jump over. His way of framing that up and saying, hardware, software, materials, and then the whole process around it. I think oftentimes when you hear people talk about that, it's hardware, software, materials, and post-processing, which to most people means I rinsed it off and dried it and maybe post-cured it if you're talking about resin printing. When we think about the process around making that part, and you and I were in a meeting yesterday with a customer talking about a customer's parts who is trying to use additive in production. And when we looked at the QA QC portion of their plan to do that, it was kind of like, here's sort of what a picture of it looks like, and make sure it's this color. Now, admittedly, these parts were not, medical device components that were going to be implanted in a person. However, with only that as the QA QC plan, you could make thousands or tens of thousands of these parts before you realized, ooh, these actually don't fit in this case of this particular part. They don't fit in the hole they need to go in. There was nothing about even a simple go, no-go gauge with some kind of AQL sampling approach that says, hey, every X prints, take one of these parts and try it in this go, no-go gauge. And we had our VP of quality and operations in that meeting. He threw out that idea. He said, oh my gosh, how come there's no just basic go, no-go type fixture involved in this? That's the power of when you get people who come from a manufacturing background in a room around additive projects. And, it comes up all the time, but when you're working with an additive company that doesn't even make their own product, and you're asking and you wonder, well, how come they didn't bring that up? Well, they don't think that way because they're not manufacturing people. They're 3D printing people. And, we just see that again and again and again as missing from what it takes to make this work. And so when we say post-processing, yes, clean it, cure it, all those things. But then back to that process around the part has to include a QA QC strategy, or you risk, this process we were looking at yesterday, this could run, the parts are not incredibly complex. This could run on autopilot for 9 months, 12 months, 2 years, who knows? And all of a sudden drift out of spec, and nobody know until these parts had not only been produced in the user's factory, but made it into tens or hundreds of their customer facilities because they don't consume the parts, they sell these parts. And it is a, recall, customer support nightmare in the making that is all very preventable with basic manufacturing tools, techniques, but we still miss it far too often as an industry.
Yeah, I couldn't agree more. Another topic that came up, and it fits pretty well with your customer example, is Tuan talked a lot about this idea of manufacturing as a service versus in-house production. You seem to have that trend. You have this other trend of reshoring happening at the same time. What's your take on that idea of maybe where additive will head? And maybe more importantly, how should customers be thinking about which direction is best for their business model?
Yep. This was an interesting part of the conversation because it's a topic that Tuan and I see a little differently, which is great. Doesn't make me wrong and him right, or vice versa. But the perspective that he sees is this. He used the phrase, like AWS, 3D printing in the cloud. Where I struggle with that a little bit is if we said, you don't need any application expertise to do it well. And certainly with some applications that are relatively simple and straightforward, that's absolutely the case and it would work well. When we think about additive in production at scale, because of the background we come from at B9 and the customer base we serve in aerospace and medical and all these things, we tend to think about more complex, more difficult, more highly regulated parts. I can't really see all that happening in an environment where the people laying out the parts, running the machines, et cetera, don't know anything about the application. We don't see that in traditional manufacturing is one of the main reasons that I take a different view. Certainly you have contract manufacturers, even a lot of the big medical device companies outsource the production, but they outsource the production to companies who are highly knowledgeable about producing the parts and meeting the regulatory requirements, et cetera, that the, Medtronic or whatever company you want to pick lives in. So I believe you're still going to see a lot of customers want to bring this in-house. We talked a little bit with Tuan about, there's some workforce challenges around that. Ultimately, what it needs to come back to is your strategy. Is being a great manufacturer a core part of your strategy? If it is, I would not be afraid of additive manufacturing coming in-house. You need to understand what goes around it. What I think Tuan was calling out, and he and I agree on this, if your strategy isn't built around manufacturing excellence, just because it's quote unquote easy or cheap from a CapEx standpoint to bring the 3D printing in-house, don't do it. You are likely to have challenges, but huge potential to, when you think about the ability to produce 2 or 3 different part families where you still have an application tailored hardware, software, materials process, but 2 or 3 different part families, whereas with an injection mold, it only makes one part, right? Unless I change some inserts or something, I can't do anything else with it. And so still a lot of flexibility there, but that application expertise, I think, is going to continue to be critical with additive, just like it has been with traditional manufacturing.
Yeah, that's good. We've talked a lot about constraints around process and kind of this manufacturing mindset. If you had to pick another constraint holding additive back today, what would it be? I think there's this whole economic angle that we haven't even touched on. What should folks be thinking about that maybe isn't coming top of mind for them to be able to scale successfully?
Well, I will, because I think Tuan did a great job covering the material properties piece. So I'll leave that one to the side and I'll touch on the economic piece you mentioned, Danny. What I would encourage, folks wrestling with, should we tackle an additive project? How do we frame it? What are the success criteria? I would go to that economic angle and I would encourage people, we've said this many times, but get a cross-functional group in the room. If you're only looking at it through the eyes of like, how many hours of technician labor to run the machine, how many minutes to post-process each part, blah, 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 blah. And you're not thinking about the supply chain considerations. How much cash are we freeing up from inventory? What can we do to inventory turns when we eliminate maybe an MOQ constraint that we have with a traditional molding process where, your molding supplier doesn't want to pull some other tool, put your tool in and run that for 2 hours and then be swapping tools all the time. With additive, you get out of some of those setup costs or setup constraints with milling and molding that you typically deal with. So understanding the economic piece really stem to stern. Another great thing that I would encourage people to think about that did come up in the conversation with Tuan around materials, but it's not properties. I would just caution people, you probably have a process for how you qualify suppliers. Don't throw that out the window when it comes to your material or hardware or software suppliers as it relates to additive. Find out how many other projects like this, how many other applications like this, how many projects that have gone to scale has this company been involved in? And when you ask them about a QA/QC plan, or you say, show me an example of one that you've done for parts similar to what we're talking about, and it's a photo that says, make sure they're kind of this color and look about like this, just run and save yourself the pain later. When we think about additive at scale, once upon a time, it was simply, gosh, the printers are slow. Could you even make enough parts? And what the industry did, so much money flowed in, a lot of it to hardware companies. Think back 5 years, and phrases have been coined like laser wars. In the metal world, it was who can cram the most lasers into a machine. So the making of the parts got a lot faster. What didn't get better at that same time was ensuring that we're making parts that all meet spec. And so the pendulum swung to the other end. Well, hey, now we can generate a ton of parts. How do we know they're good parts? And so we're having to go back and work on that. But like the example that I shared from the meeting Danny and I were in yesterday, where immediately when our VP of quality and operations was in the room, he said, how come there's not a basic go, no-go gauge that gets done here on some kind of AQL basis? I bring that up again to say it is a challenge for our industry, but the answer is simple. That doesn't, the old saying about easy say, hard do, but the answers aren't rocket surgery. We just have to be disciplined in applying, good manufacturing principles to these projects.
Great. What a great conversation.
If there's one theme that stood out in this conversation, it's this. Additive manufacturing doesn't win on technology. It wins on outcomes. Whether it's materials to process to production economics, the gap between what's possible and what's scalable is still very real, but it's also where the biggest opportunities exist. Whether you're working on those challenges inside your organization, if you're thinking about how to move from experimentation into real production, this episode gave me a lot to think about, and I do this every day. I hope you found it valuable as well. That's why we have these conversations.
Absolutely. Thanks for spending that time with us today. If you have questions, ideas, or want to continue the conversation, we'd love to hear from you. You can connect with us on LinkedIn or reach out directly at info@additiveadvantage.services. And if you or someone you know is actively working to scale additive manufacturing, drive production adoption, or solve real-world manufacturing challenges, we're always looking for great guests to feature on the show. You can follow us on Apple or Spotify podcasts or watch this episode on YouTube at the Additive Advantage Podcast. And if you found value in today's conversation, give us a 5-star review on Apple or Spotify. It really helps us continue the show. And make sure to follow us on LinkedIn so you don't miss new episodes. Thanks for spending time with us. We'll see you next time.